Hello friends, welcome back. In my previous video, we discussed about the concept and introduction of red-black tree and its properties. In this video, we'll be discussing with the help of an example how to color a red-black tree. So we have been given a small red-black tree over here with nodes 7, 5, 9 and 12. And for reference purposes, I've also mentioned all the properties here again to simplify the task. All right. Now, if we start with the simplest configuration of coloring, let us start with property number 5 that the root is always black. All right. So let us give 7 and let me select the black color from here. All right. So let me give 7 the black color. All right. So I'm giving root as the black color. So I'm complying with property number 5. All good. Now, every node is either red or black. We haven't mentioned any color red right now. So, in this, all the five properties, there is no restriction on that if a node is black, what about its children? So, if a node is black, the children can be red also and they can be black also. This is imperative to note that there is no restriction for the children of a node which is colored as black. So if a root is black, the children can be either red or the children can be either black also. There is no restriction as such. All right. So let me give its children red color. So if I give both 5 and 9 as red color, so the root is black and the children are red. That's all good. If I have to think about coloring node number 12, I'm left with two options. I'll tell you both the two options. But for instance, if I color node number 12 as red, then what will happen? Now we'll have this type of scenario. That means the root is black, that is all good. But both 9 and 12, that means adjacent nodes are red, and that is a violation of property number 3. For reference, I'll show it to you again. If a node is red, both the children are black. We cannot have two consecutive reds on the same path. And that is why this type of tree coloring is not appropriate. That means we need to fix the coloring of the tree. And let us give another interpretation for coloring. So in order to recolor the tree, if in case I give this type of coloring, you know, that means I give 5 and 9 as black color, 12 is red, but I give node 7 as red color. Now that is definitely not appreciated because the root is always black. And this is where we started from. So the root cannot be red in color. That is a violation of property number 5. So even this type of coloring is not appropriate. Let us think about another option. In case I give my tree this color, so I color root as black, that is fine. If I give both the two children, 5 and 9 as red color, that is also appropriate. If I give node 12 a black color, then what happens? I mean, in terms of the features and the concept of property number 1, every node is red or black, it is all fine. Every leaf node is black, that is also fine. If a node is red, the children are black, that is also good. Root is also black. But this type of coloring creates a problem. Let me just prepare the leaf nodes for convenience purposes. All right. And now I'm going to explain you what does the black height means. The property number 4 states that every path from node to the descendant leaves, that means we will go from top to bottom, contains the same number of black nodes. So we need to count the number of black nodes if we start from a node and go downwards. All right. So in case, let me compute the black height of node 7. The first thing and the most important thing to note over here is that if we count the black height of a node, we will not count that node itself. Alright. So if I want to compute the black height of node 7, how many alternatives I have? I have one left subtree with respect to 7 and I have right subtree with respect to 7. and black height of 7 with respect to left subtree and with respect to the right subtree, it should be absolutely the same. All right, so let's compute that. If I want to compute black height of node 7 excluding the node itself, how many black nodes do I have? So I have a path from 7 to 5. Now 5 is red in color, so I cannot count that. And then I have one black node towards the left leaf node of node number 5. So over here I can say that right now in path 7, 5 and left leaf node of node 5, the black height is 1. If I compute towards the right leaf node of node 7 of node 5, then also I have 7 to 5 and 5 to the right leaf node. So again, how many black nodes do I have? In path 7, 5 and left leaf node, I have one black node because I'm not counting the node 7 itself. And on the path 7, 5 and right leaf node towards the right of node 5, I have again one black node. So in the left subtree, I can say that the black height of node 7 is 1. Okay. Now if I compute the black height of node 7 towards the right subtree and not counting 7 itself. So if I go down from 7 to 9 and the left leaf node of 9. So over here I have one black node. That is all good. If I go further down, I will say 7, 9 and 12. So one black color, one black node on node 12 and another black node towards the right leaf node of node 12. So over here the height becomes 1 and 2. And if I go towards the left leaf node of node 12, again the height becomes 1 for node 12 itself and 2 for the left leaf node of node 12. So in this case, guys, the black height of node 7 for left subtree is 1 and black height of node 7 for the right subtree is 2, and that is inconsistent. That means this type of coloring is not appreciated because even property number 4 should be complied. Alright, then we need to again recolor the tree. So the only and the best alternative which we have is this is the final fixed red-black tree. Now let's check all the properties for compliance. The root is always black. Yes, the root is black. Every node is either red or black. Yes, every node is either red or black. Every leaf node or the null pointer is black. We are complying with property number 2 as well. If a node is red, both its children are black. Node 12 is red and its leaf node children are black. That is fine. Every path from node to the descendant leaf should contain same number of black nodes. Now let us again compute the black height of node 7 with respect to this coloring. So if I check in the left subtree and not including node 7 itself again, alright. So I have 7 to 5, so one black node as node 5 and another black node as the left leaf node of node 5. So the black height of node 7 is 2. Even if I go towards the right leaf node of node 5, so I have one black color, one black node on node 5 and another black node as the right leaf node of node 5. So over the left subtree, I'm sure that the black height of node 7 is 2. Alright. If I go towards the right subtree, let me compute the black height of node 7 towards the right subtree and definitely not including the node itself. So I have one black node and node 9 and another black node as the left leaf node of node 9. So the black height over here is 1 and 2. If I go down, I have 7, 9 and the right leaf node of node 12. So one black node for 9 and another black node for the right leaf node towards the right of node 12. Alright, so over here also 1 and 2, the black height is 2. Even if I consider the left leaf node of node 12, so I have one black node for 9 and another black node for the left leaf node of node number 12. So the black height of node 7 for the right subtree is also 2. That is, I comply with property number 4 as well, that every path from node to the descendant leaf contains same number of black nodes. Alright? Now for further insertion in red-black tree step by step and preparing the tree from scratch, stay tuned for my next video. Thank you.